Today we are going to discuss about module 6 of microprocessor and microcontroller. Here we are discussing about 8051 logic instruction. What is meant by a logic instruction? Logic instruction perform logic operation upon corresponding bits of two registers. If there are two registers are given, then it perform logical operation. There are different types of logical operation, and, or, XOR, etc. So it perform that operation on bit of that two registers, and after execution of that, or after perform the operation, the result will be stored in the first operand. For example, here there are three types of logical operations are the AND, XOR and OR operation. Here one of the example is here AND ANL A, 0 AH. A indicate the accumulator. Here accumulator address is E0H, that containing accumulator containing the data 80H, and 0AH, the A0 is the direct address is here. It indicate the P2 is port 2, and the data in the port 2 is 08H. Then perform the AND operation on this 80H and 08H, and the result will be stored in the accumulator. Here after performing AND operation, 80H is 10008, 80 means 000, and operation 00008 means 1000. This is accumulator content. First one is the accumulator content, this is the A0 content, and perform the AND operation. Both inputs are 0, output will be 0. So 0 0 0 1 0 also AND operation. So 1 0 bitwise AND operation is performed here. അപ്പോൾ ഓരോ ബിറ്റിൻ്റെയും ബിറ്റ് വൈസ് ആൻഡ് ഓപ്പറേഷൻ ആണ് ചെയ്യുന്നത്. അപ്പോൾ സീറോയും വണ്ണും ആൻഡ് ചെയ്താൽ സീറോ തന്നെയാണ്. ബോത്ത് ഇൻപുട്സ് വൺ ആണെങ്കിൽ മാത്രമേ ഔട്ട്പുട്ട് വൺ ആവുള്ളൂ. അപ്പോൾ എല്ലാ ഔട്ട്പുട്ടും സീറോ വരും. അപ്പോൾ ഔട്ട്പുട്ട് എന്ന് പറയുന്നത് എന്താണ്? 0 0. Here it shows 0 0. സോ റിസൾട്ട് എവിടെയാണ് സ്റ്റോർ ചെയ്യുന്നത്? ഫസ്റ്റ് ഓപ്പറാൻഡ് എന്ന് പറയുന്നത് ഏതാണ്? അക്യുമുലേറ്റർ ആണ്. സോ അക്യുമുലേറ്ററിൽ തന്നെ, അല്ലെങ്കിൽ ഡെസ്റ്റിനേഷൻ ഓപ്പറാൻഡ് എന്ന് പറയുന്നത് അക്യുമുലേറ്റർ ആണ്. അക്യുമുലേറ്റർ റിസൾട്ട് സ്റ്റോർ ചെയ്യുന്നു. സോ ദിസ് ഈസ് ദി ഓപ്പറേഷൻ. സോ ബിറ്റ് വൈസ് logical operation, either it is AND, XOR or OR operation is performed. And next, AND operations. This is AND operation. ANL ARN. Here RN indicates the register, any register from R1 to R7. R0 to R7. There is 8 registers are there. So it perform AND operation on RN, that register content, and accumulate. Then ANL A, direct. Here AND direct byte, or byte at this direct address. So previous case A0 containing the address data 08H. So that data, that byte at that direct address, and with AND operation performed with accumulator. The next one, ANL A, at the rate RI. Here RI indicates the byte from the address pointed by RI. So this location byte and the accumulator content perform the AND operation, and result will be stored in the accumulator. Then ANL A, hash data. Hash data is the immediate data. The immediate database and with accumulator content. Then ANL direct, A. Here and A with byte at the direct address. So whatever address data in the accumulator and the byte at that this address is will be and after result will be stored in the direct, that memory location. result will be stored in that memory location. Then ANL direct comma hash data. Here hash and with immediate data byte and the byte at this direct address, and the result will be stored in the direct register. Then next is OR operation. So bitwise OR operation performed on the data on both register. Here Rn and A, the data in the Rn and A will be perform the OR operation. For example, accumulator containing 1001 1000 and the register R1, if for example or A comma R1, then R1 containing the register data 00010000, then output will be, both inputs are 0, output will be 0. Then here 0 1 output will be 1, both 1 output will be 1. OR operation 1 or 1 or 1 0 0 0 0 1 1. So this will be the output after the OR operation on A and R1, and result will be stored in the accumulator. That is A, first operand. So here OR A comma direct. So byte at this direct address. This byte at this direct address OR with accumulator content, and result will be stored in accumulator. Or A comma Ri. So for example ORL A comma at the rate R1. So R1 is the register, the address, this is the address, and that address containing 80. So that 80 location containing the data 0H and accumulator containing 80H. Then perform the OR operation on these two data, and output will be stored in this accumulator. Then here ORL A comma hash data. So hash data is the immediate data. OR operation is performed on immediate data byte and the accumulator, and result will be stored in the accumulator. And here ORL direct comma A. Here OR accumulator to direct byte, and ORL direct comma hash data. So here immediate data byte, OR operation performed on the immediate data byte and to the byte at this address, and the result will be stored in this address. This is what is the addressing mode. It is a direct addressing mode, and the length of this byte is 3. And how many cycles are required to complete? 2 cycles are required to complete the operation. Then next one is XOR operation. So XOR operation. XOR operation perform the XOR operation between the bit by bit XOR operation between the two registers. Here XRL A comma Rn. Here accumulator content is XOR with Rn register content. This addressing mode is register addressing mode, and the length in bytes is 1 byte. And how many cycles to complete the operation? Only one cycle is required to complete the operation. So next one is XRL A comma direct. Direct means the byte at this direct address is XOR with accumulator content, and result will be stored in the accumulator. XRL A comma at the rate Ri. Here the Ri indicate the register R1 or R2, any of the register, sorry, R0 or R1, any one of the register, and the byte at this address location XOR with the accumulator, and result will be stored in the accumulator. XRLA, this XRLA XRL A comma hash 0 to h. Hash data means immediate data, here 0 to h. So it's represented as 0 0 0 0 0 1 0. Then A containing the data, accumulator containing the data 0 1 0 1 1 0 1 0. Then what will be the result? Here bit by XOR operation take place. So 0 0 similar input 0 output, 1 1 0 0 0 0 0 1 different XOR operation, different input, output will be 1. Here different input, so output will be 1 0 1 0. This is the result after the XOR operation, and the result will be stored in accumulator. Here first operand is accumulator, or destination operation operand is accumulator, so result will be stored in accumulator. XRL direct comma A. Here XOR operation performed on A and byte at the direct address. So the byte at this direct address XOR with the accumulator content, and this is the direct addressing mode, and it requires 2 bytes. And how many cycles are required? Only 1 cycle is required to complete this operation. Then XOR direct comma hash data. Here hash data is the immediate data byte XOR with byte specified in the at the direct address. So it is a direct addressing mode, and it requires 3 bytes. And how many cycles are required to complete the operation? 2 cycles are required to complete the operation. So these are the XOR operations. Then next one is next operations are data and bit manipulation instruction. Data byte manipulate instructions are clear, complement, rotate, swap, etc. Then Boolean variable or bit manipulate or Boolean processing instruction like CLR, set-B, CPL, ANL, ORL, and move instructions. Next, CLRA. CLR means clear. Here it clears accumulator content. Accumulator content is clear the all bits at the accumulator. That is clears the accumulator. These all instructions are length is 1 byte. Also it's how many cycles are required to complete? Only one single cycle is required to complete the operation, and these all are register addressing mode. So here we are representing the register. Which register? Accumulator register. So CLR means clear accumulator. CPL means complement. Complement the accumulator. That means it converts ones to 0 and 0 to 1. Whatever content in the accumulator. If the accumulator content is 1 0 1 0 0 1 0 1 0, it converted to 0 1. After the execution of CPLA, this will be converted to 0 1 1 0 1 1, like this. That is complement accumulator content. Next one is RRA. What is RRA? Rotate bits in accumulator right. So here rotate the bit right. RR means rotate bit right with LSB, rotating into MSB, and also to C. C means carry flag. So here RRCA. RRCA means rotate bits in the accumulator right through carry. That is, rotate the bits right with LSB rotating to carry and carry to MSB. What is the difference between these two instructions? RRA, if this is accumulator content and this is carry, this is LSB and here it is MSB. Rotate right means here rotate to right. So LSB is rotating into MSB, and also it is rotate to carry. This is RRA. Then what about RRCA? RRCA means here this is LSB, MSB. Here each bit is rotated to right, and LSB is rotating to carry, and carry is rotated to MSB. So this is RRCA. Then what about RLA? Rotate to left. Rotate to left means this is accumulator content, and here LSB, this is MSB bit, and this is carry bit. Here each bit is shifted to left or rotated bits left, and MSB is rotating to LSB, and is also goes to carry. But what case of RLCA is rotate bits in accumulator left through carry. So here instead of here it is MSB is rotated to MSB is here, this is accumulator MSB LSB, MSB LSB, and this is carry. Here MSB is rotated to carry, and carry content is rotated to LSB, and each content is rotated to left. This will be happened in RLCA. Rotate left through carry. Then last one is swap A. Swap A means swap the nibble lower and upper hex bits of A, or swap the nibble with the accumulator. For example, accumulator containing 1001 0001. Then after executing swap instruction, it will be exchanged to here, and it's here, that is 0001 and 1001. So it will be swap the upper and lower nibbles. So these are the logical instructions. Thank you.